All right, everybody. I want to thank you for being with us tonight. This is being recorded, by the way, just in case you need to know that. We are GDG Memphis, Google Developer Group Memphis. We're a group backed by Google developers. My main goal is to provide whatever resources I can to developers that need it, provide a very comfortable and inclusive environment of everybody. So thank you for being here. I hope you feel comfortable. I know I've been cracking a lot of jokes before we started recording, trying to make everybody feel at ease, and I hope you are. But a couple things I want to touch on. And one of them, obviously, we're in crazy times right now with the whole pandemic, the job situation. It's an estimated 30 million Americans have lost their jobs. And I was even on a live stream talking about this yesterday. And I just want you to know that it's absolutely possible that you can gain employment, that you can do amazing things, and you can reach your dream job. And it may be harder than usual right now. And one thing that I always say is if you really want to get a job in tech, and there's one thing that you can do that will guarantee you a position. You just need to be so undeniably good that you can't be denied. Like you need to be so undeniably good that they want to be like, I wish I could turn him down, but I can't. He's so good. Or I wish I could turn her down, but she's phenomenal. Be that undeniably good and you will get a job. If you have a difficult name, be so undeniably good that before the interview, like, what is this name? And then after that interview, they're practicing it. Be that good and you will get a job. So undeniably good, keep that in the back of your mind. You need to remove any possible doubt that they need to look anywhere else. I always say, if you could provide value, they will be interested. No one has ever turned down an opportunity to make more money. So if you bring value, they'll bring a checkbook. It's as simple as that. You need to demonstrate that. So demonstrate your passion for tech, demonstrate your abilities, whatever you need to do to set yourself apart. Because one thing I tell people all the time too is the bar has gotten kind of low as far as entry into tech, which is amazing, which has produced a lot of opportunities for many other people. I mean, especially in tech, we still have jobs going unfulfilled. So that's phenomenal in that respect. But the other thing you have to think about is if the bar is that low and you know the bare minimum, there are a lot of other people that know the bare minimum. You may want to learn a couple additional things to set yourself apart. I'm not saying it's impossible to get a job knowing the bare minimum, but I am saying it's not going to be easy. And, for me, for those of you that don't know, I come from the gas station industry. I worked in gas stations for over 10 years. And there came a point where I said, okay, I need to change this up. I need to make a change. So I looked at myself one day and I said, I'm at the bottom right now and I don't belong here. Like, I need to pick myself up, get my butt up and go exactly where I belong. And it damn sure isn't flipping, frying chicken at the gas station, ringing up customers. That ain't it. So, and it gets on this interesting idea for me because I feel like we all amplify greatness as this immaculate thing that only is, positioned for a couple few people. Like you always see these people hit these amazing milestones like, oh, well, they're great, chalking it off. Greatness isn't allocated to a definite amount of people. It's in literally all of us. Like greatness is in all of us. We believe, to some degree that greatness is a gift reserved only for a few, like the geniuses, the superstars, the celebrities, the artists. But for the rest of us, like we can only watch it and it's not true. Like greatness is literally in all of us. Greatness is in you. Trust me when I say that greatness is absolutely in you. You've got it. The only thing you need to do is stop capping yourself. Stop capping your own success. Get out of your own damn way so you can reach where you're supposed to reach. I always say, for me, my goal was never to be a junior developer or entry-level developer. My goal was to be the most valuable developer I could be for a company. So if that's my goal, of course, a natural stepping stone was going to be a junior developer. It's a natural stepping stone. You're not going to get to B without going through that. So of course, I was a junior developer. And almost immediately, I was promoted from that position. And I was promoted within 3 months of being in that position. You can reach wherever you want to reach if you just stop capping your own success. And one thing that will just kind of tie this all in for me, the reason why I even made the transition and the change was because of my definition of what failure is. Failure to me is waking up every single morning and doing something that I just don't want to do. Simple as that. Like failure to me is literally waking up, going to work, still busting my butt, and I'm working hard enough just to still be called broke. And I'm going into these situations miserable. Life is so short. It's so incredibly short. Life is, you could be here today and you're gone today. Like there's no definite answer for any of us on the lengths of our lifespan. The only guarantee I have for everyone in this chat right now is that sometime, someplace, somewhere, our last day is going to be there. And I don't want my last day to be me leaving work one day, bone tired, exhausted, and miserable because I'm doing what I'm doing. If you're going to leave on your own terms and leave happy doing what you want to do. And I really, 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 really want to stress that I want to celebrate your success in any way I can. Give me a reason to celebrate you. And the only way you're going to give me a reason is by doing exactly what you need to do. Study, put your fingers on that keyboard, create some code, build some things. Let those fingers dance, let them free. You don't have to keep them constrained to yourself. Let them go. Be focused, be diligent, be phenomenal. Thank you. And now, without further ado, I'm going to introduce our amazing speaker today, James Perkins. He's written a book on Golang. He may know a thing or two. He, I've been talking to him for quite some time online, and he's an amazing human being, and I'm very glad to have him here with us tonight. So if you have any questions, please put any questions you have in the chat. And one thing that we do is, unless the question is pertinent to what he's talking about at that moment, we will ask all the questions at the end in the Q&A section. So make sure you leave them there, and we will monitor the chat. And James, for you, if there's anything that is important that is asked, I will interrupt you and ask that question for that person. So there's no need for you to get distracted or pay attention to the chat if you don't need to. And one more thing I will say is, if you're not following me on Twitter, I genuinely don't know how you know about this event today. But if you are not following me on Twitter, add me on Twitter, twitter.com/DThompsonDev. All my social media is the same. YouTube is the same. Instagram, my eHarmony profile. No, I'm kidding. My wife will kill me for that joke. But the last thing is, I have a podcast called Commit Your Code, where I get to interview some really phenomenal people in tech and talk about their journeys in tech. So please definitely check that out. The last interview was with Jamie McGuire, who literally was a dairy worker. He worked his way up and he became a developer. And from becoming a developer, he became a Microsoft MVP in AI. So you can come from very humble beginnings and still make your dreams come true. And he's a huge testament to that as well. So now, Mr. James Perkins.
Thank you. I guess I can't really top what Danny just said, but let's talk some code. Let me share my screen. Oh, can you let me share screens, Danny? I got a bunch of stuff. And while he's doing that, I'll be patient, I suppose. Well, there we go. All right, let's see here. Screen number 2. You all should be able to see my wonderful screen now. Go crash course. Just a thumbs up from anyone, just to let me know if you can see it, because everybody's muted right now.
Yep,
cool. All right. So we're going to talk about Go today. But before we get that, let me just tell you who I am, what I do. So I've been a developer since 2010. Developing since 2008. I learned Java from a really old book that I bought on the internet for $1. And it was terrible and it was horrible. It was the worst experience of my life. But that's how I learned Java. And then I've worked at a few companies, Cox Automotive, IGT, who do the gambling stuff down in Vegas, and they do the lottery in all the states. And now I work at Plaid, who do fintech stuff. And this is how Danny and I know each other. I do YouTube, I do Twitch, I do a lot of stuff on Twitter, and I do a lot of mentoring. And then finally, I wrote a book about Go because after my horrible experience learning Java from a book, I decided it would be better for me to write a book, how to learn something in the way that felt more natural for a developer and didn't just kind of dump you into an application and say, hey, this is how we've written it. Now you're going to do the same thing. So what are we going to cover today? We got the basics of Go. What is it? We're going to do some variables, constants, a few of the loops, arrays, slices, structs, and this will all make sense, I promise. And then we'll do some live coding. We're probably only going to do the first one. If you come to DevFest, we might do the second one instead. And then we'll do Q&A. So what is Go? Go, open source programming language. It was created by Google when Java and C were really popular. And the reason it was created was Java and C were really strict, and then Python was the complete opposite. It was really just too fluid for Google, apparently. Now, this is the rumor I've heard. So is it Go or Golang? It is Go, but apparently Go.org was not available when they tried to buy the domain, so Golang it was. And it's a rich type system, so it has a lot of multitude of types, which we'll get into, and it represents data of many forms using these types. So let's get into Go basics. Let's talk about Go and very simple stuff. So if you've used Go before, this might be really simple. And if you've never seen Go before, you'll probably be at the end, still think, what am I doing? But let's see what we can get to. So simple variables in Go are fairly similar to something like JavaScript. If you've ever used JavaScript before or any of those kinds of languages, it's literally just var, the name, and then whatever type it might be. And I say the word whatever type it might be because in this example, Go will actually infer that there's a type here of string, which means that once it's set to a string, you can't accidentally set it to an integer afterwards. So when you're coding away and it's late night and you've come up with this great idea, which has happened to me thousands of times, and I thought I used an integer and I actually used a string. And when you get to the end, when you try and compile something, Go will say to you, nope, sorry, you said this was a string earlier and you put an integer down here. Like, you can't do that. Go back and change one of those two, make sure it works right. And then you can just declare the variable and its type at the same time. So down here, you can see that I set var1 to an integer. And down here, you can actually just say var2 integer equals 2. And I promise there is actual code that you're going to see, but I'm going to do all the variables at once, and then we'll go and look at some code, and I'll show you kind of how it works. So Go has this fantastic feature, I think, probably one of the best features that it has, is that you can do a shorthand for your declaration and assignment. So instead of having to write out this every single time you want to do a string, you can actually just do this. And that will set it to a variable and set the type to string, all in this nice little shorthand. The catch is you can't do it outside of a function. So if it's outside of a function, you've got to put the keyword in there. But when you're inside a function and you're doing a bunch of stuff, you can shorthand all day. Excuse me. And you can declare multiple variables at the same time. So imagine if you know that you've got two integers at the same time, you can just go ahead and click, var width and height and set them to int, and then you can just assign the numbers right afterwards. You don't have to do one on each line. You can just do it all in one big line. You can even just ignore the type because it knows it's already an integer here, or you can get real fancy and do one of these. So you've declared what they are, and then you can set them afterwards. So that's the basics of the variables. And we're going to move on to constants in a minute. But first, let's do a quick look. And I want to make sure that that screen is, like, everyone can see that and it's big enough. Let me know if it's the type is not big enough, and I'll make it even bigger than it is now. But I think it should be good. Let me see. Danny, is that good? Can you just give me a yep? Or anybody?
It's great.
Okay, perfect. Good. I don't want anyone to be squinting for the rest of the night because we've already had long nights. So here, what I did was I just dumped out what was over those few slides, and I put them in a function. And I'm just going to quickly go through how a Go how a Go file is laid out so that you can kind of get a good feeling. So it always has to have a package, and at minimum, it has to have a main package. You can think of that if you've ever coded in Java, there's always that main piece that runs everything. It's the exact same thing in Go. So anything inside of this main will run at the time that you run the file. Anything out of it, if it's not called in the main, it won't run, and we're in that kind of situation. So I want to sort of show you how this works first and what prints out, and then we can just kind of talk about each line as we go. So let me just, there we go. Not enough for too many computers in my house. So to run a Go file, hopefully you can kind of see in the terminal. Let me just bring it up a little bit. So you can use Go and then run, and then whatever the file is. So for this one, I had to put it in a separate file. But what happens here is Go will actually compile the file and then run it afterwards. Similar to sort of when you compile, if you've ever used Java, you have to compile it and then run it afterwards. It's the same kind of idea, except from it does it in one line.
One question is,
yes,
is the package the equivalent to a namespace?
Yes, similar thing, yep. So go ahead, and when you hit enter, Go will compile this and then run it. And as you can see right here, it printed out everything that I asked it to print out. So let's just move this down so I can kind of explain a few things. So this one is fairly self-explanatory. It's a very simple variable. It's a type of string, and we've just printed that out. And here is my example of doing multiple variables at the same time and setting something to that figure. Now in Go, if you set a integer without any assignment afterwards, so you've just declared this will always be 0. So that makes it kind of a good like check if you've accidentally forgot to use one and you've printed it out and it comes out as 0 and you were expecting 6 million. That's a good example of what would happen. And then here, it's just that nice shorthand. I used the word apple, not sure what I was thinking at the time. But yeah, that's just the shorthand version. And that's the same as doing this, but without having to type var, and there's actually this involved too. So this here is equivalent of just writing this. So it's very shorthand, it's very nice, makes life a little easier sometimes. Let me flip back. So constants, they're exactly what they say on the tin. Just as the name sounds, it's fixed, can't be changed, or it won't be changed. It can be used anywhere a var can be used, similar to JavaScript and ES6, sort of things like that. Constants can be characters or strings or a Boolean or a numeric value. And they can't use the shorthand syntax. So in this example, I just did, this truth equals true. And this, obviously, we all know that pi is 3.14. And that will never change. Suddenly tomorrow, pi is not going to be 6.56 or some other random number. We all know that. So you can use a constant so that you don't have to accidentally reassign it to a different figure, because Go gets really mad when you try. So looking at constants, in this example, what I did was I used the same const truth equals true, and to prove what will happen, I've just set this to false. So in theory, it shouldn't do anything, like this should always return true. But in Go, when you do something that you're not supposed to, which I like to do often, you get this nice, helpful error message. Not that one. Let's try one more. Live coding is always fun. There we go. So it gives you that you can't assign to truth. So it's basically saying to you, like, nope, you already told me this is going to be true. You can't set it to false. So instead of having to debug this when you've got it in runtime and you can't figure out why something's not working the way it's supposed to, Go will help you out by saying, hey, you already did this before. You can't do it now. So that's one of the benefits of Go for sure. So looping is super easy in Go because you don't have to remember a lot of them. In Go, there's a for loop, and for loops are the only thing in Go. So you don't have to remember while, do while, for in, for of, all those crazy loops that you have to remember in other languages. Go has one loop, it's the for loop, and you can use it in a few different ways, and I'll show you a couple of them today. Now, this immediately to me appealed when I'd been in the Java world for a long time, because I just hated remembering do whiles and all the other kind of crazy loops that we have in the industry. So the 3-component loop is the basic for loop. It's exactly what it says on the tin. It has 3 components, and it's the basics. It has the init statement, which is executed before the iteration, the condition, which is evaluated, so it checks to see if something is true or false, and then finally the post statement that executes at the very end of the iteration. So this is a very simple for loop. So we have this, which I've just set sum to 0. This part right here is the init. So this part is the init. Now this part is the condition that is evaluated. So it says, is I less than 5? And this is the post. So if this is false, so I is less than 5, we can go in here and say, okay, add 1, add sum, add I. So if I is 0, sum plus 0 is 0, and then we make I 1 more. So that's how the simple 3-component loop works. And now I can show you kind of what it looks like in the real world. So again, we're using the same, I tried to keep this as simple as possible, basically because I wanted to appeal to everybody. Even if you're a pro in Java, you're not a pro in Go. So it's the exact same thing. And what will happen here is we'll see a nice printout every time this loop happens, and we should get the number 10 if I know my math correctly, which I've told I'm pretty good at. So let's see. Go run, and this one is, what did I call this? For loops? There we go. And there we go. So each one, it evaluates and adds until it gets to 5. And as we're adding these up, it's going to equal 10 at the end. Now, for loops, super, I think if anybody's ever touched code, they've probably done a for loop at some point. And they've probably done a while loop as well. Well, Go doesn't have a while loop, but the pattern exists. So the init.
I have one question.
Yeah, go ahead, man.
Can you briefly explain what the import FMT stands for?
Yeah, so this
Like
is this is the equivalent of importing like a package from somewhere else. So this FMT is essentially a way to do print lines. Similar to like if you've ever done Java and you do the import statement at the top, or if you've done any JavaScript recently, maybe Node, and you do the import statement at the top. It's the same idea. You're importing another package from somewhere else in the Go sphere. And this import happens to be from like Go's core library. It's not something I'm using outside of the core library. So that's why it's just a simple import. Does that answer the question? I hope so.
It does, yes, perfect.
Okay, cool. So back to this sort of while loop. The init and the post statement are optional. So you don't have to include them, which essentially makes a while loop, because basically all that's left is the evaluation part of it. It just says like, you know, a 4 and then maybe numbers is less than 5, add 1 to that number. And that's exactly what we've got sort of going on here. So I set the number to 1. If the number is less than 5, we're going to do the number multiplied by 2. Unfortunately, apparently Google Slides just likes to add, you know, uppercase to everything, and I can't always win. So I'll give you an example of the while loop, as we'll call it. which is, you know, the exact same thing. We just added a print statement again, same kind of package structure. And for this, and let me know if I'm going way too fast or anything like that. So you can see from here, it just does the loop 3 times, because after it gets to 4, it does it one more time, and then 8 is definitely greater than 5. The while loop in Go, although it's not technically a while loop, it does the exact same thing. So if you have an understanding of while loops for Go, it's the exact same structure. We will come back to loops later, but we're going to move on to arrays. And the last loop that I will show you actually involves arrays and slices. So arrays in Go are a little different than other languages. Arrays are a specific length, and which is different than somebody in the background there. Okay, we're good. So yeah, arrays are a collection of items. The index starts at 0, similar to other languages, and is a specific length. So unlike in JavaScript or Java, you can sort of flex yourself into any sized array. In Go, you set the array size, and then you use that however you want to do it. So for me, this was a little bit daunting at first, because obviously I was so used to like JavaScript where you can just, your arrays can be as big as you want, small as you want, whatever. But in Go, arrays are a fixed length. So this array is just an int array, and all I've done is just added the numbers 1 through 5. Obviously, int arrays start with 0, and then they go through to 4 to make 5. It's fairly similar in structure to other languages. And so I can kind of show you a few things for those. So let's see here. I've got so much code for you guys. Arrays. So again, I just pulled that down. And first, let me just print this out and show you what it looks like if you were just to print an array using the print line function. And then I'll show you how to access a specific array element in case you just needed like the number 3, for example. So again, it's still Go run, and we're doing arrays this time. And down here, we'll see that it prints out 1, 2, 3, 4, 5 nicely, which is a benefit if you've played with other languages and you try and print arrays. You'll find that they don't print nicely. Usually you have to do something to them to print them nicely. Same with sort of objects and things like that. But with Go, you can just print them, and Go does some stuff and makes it look nice for you. To access a specific array element, you can you can just ask for that one. So you can just say, like, I want to print this line. I'd like int array, and then use the square brackets, and then you just tell it what number you want. So in this example, we want the number 3, which will be 4. And if we run this one more time, we get the number 4. And that's, I think probably every language has accesses the same way. But I want to make sure that you understand that like you can do the same sort of manipulation. And that's that part for sure. Now slices, which aren't the pizza slices that I wish I was eating right now, are flexible. So instead of an array which is fixed size, I'm going to give you 5 elements. With a slice, you can just say, hey, I don't know what size it's going to be today. Maybe it'll be 4, maybe it'll be 400. Maybe Danny adds 1 and then Sam adds 1. Like, it's basically flexible in any way. And in my opinion, just use slices. Unless you really know that it's only going to be 1, 2, 3, 4, 5, or you know for sure 100% that it's going to be a fixed length, just use a slice, because otherwise you'll end up in a world of hurt when suddenly something is now 5 elements and you set it to 4. So slices look sort of similar to the way an array looked before. but with a slight change. So these are my favorite foods. Maybe not apples, but I do like a good apple occasionally. So you declare it with the symbol that I showed you for shorthand earlier. And then you set the type here. So this is going to be a slice of strings. And you can set them by using the commas. So here I have popcorn, pizza, hot dogs, and apples. And if you want to add to the slice, it's as simple as just using the append function and saying food equals append, and then whatever the original slice was. So this says food, but it's supposed to be food, spelling mistakes. And then the burrito, and that will add burrito to your list. So looking at slices, we can prove that this all works. So here we have foods again, and maybe it kind of looks like an object maybe to some people because we're using the curly braces. So if we print this out, again, Go will do the niceties for us. We don't have to fight with it and try and loop through them to print them out. It will just print them all out. So there we have popcorn, pizza, hot dogs, and apples. Now, if we go back here, we can see that this is how we append something to it. So if we write foods equals append foods, and then whatever we wanted to add. And then we can print that afterwards. So we'll just print something out here that says foods, exactly the same. And now what should happen is you should see two prints come out, and one will be the original one that we did, and then the one that we manipulated by adding one more. And as long as I know how to code, there we go. So we have popcorn, pizza, hot dogs, and apples, but truly my favorite food is burritos, so we'll add that to the end of the list. It's fairly flexible. You can do a lot of things with them, but I don't want to go too deep into all the fancy features we can do. But that gives you an idea of how easy it is to manipulate a slice. So we have one more loop, as promised. The for each loop, which is, it's not really a for each loop. It's just another for loop. The for each loop uses a new expression called range, and this magical loop can be used for arrays or slices and maps, which we're not going to cover today, but essentially it gives you a way to loop through and iterate through stuff. So here's the example. Again, we use my favorite foods minus the burritos again. And this is the new loop. So now we can do something like this. So we have the index and the value here. And these are going to be what we essentially assign something to. And then on this side, we declare the range, which essentially what it's doing is counting how many elements are in here. And then we have the food, which is the strings inside of it. And then all I'm doing is asking to print this out. Now, when I show you this in a minute, we're going to do a couple different things because there's a fancy feature in Go that I like, and we'll show you how to do that. But what will happen here is we'll print out the index and the value at the same time. So let's get into that one and show you what it looks like. So here we have the exact same loop, and we're using the same slice as before. So what I'm going to do here is I'm going to print this out, and then we're going to talk about what it prints and what you might want to do. So as you can see, what happens is it actually prints out the index and it prints out the popcorn. Well, that's kind of frustrating. So why don't we delete this out, right? Because we don't care about it. So let's just do that. Okay, we can't do that because the index is declared but not used. So we've declared this variable and Go is like, sorry, you've got to use this. We don't waste memory around here. We were created by Google. You've got to use all of it. Okay, so Fine, we'll just delete this out instead. So now we're only asking for the value. Let's go ahead and print that out. Okay, now it's even worse. Now we don't have any data except from the numbers. So in Go, there's a feature that is called the underscore. And the underscore essentially tells Go, I don't care about this variable. I don't want anything to do with it, but I know you require it to make this work. So what will happen now is when we print this out with the underscore, instead of getting the count, we'll just get the value, which for most people is all they want when they're looping through something. Occasionally you might want the variable index number in case you want to check where it is in your slice. So maybe you do want the fifth element. You want to make sure that it's the actual one and not something else. So if we print this out now, what we'll get now is a nice printout with just what we wanted. I just want the values. I don't care where it lies because they're all my favorite foods. So who cares which one I pick and which number it comes at. Well, that was just what I explained. So the last thing that we're going to really cover today, or at least I'm going to show you, is structs. And structs are like a typed collection of fields. They're used for grouping data together. Imagine if you had a big form on a website and it had all our contact information, right? Which is the example I'm using here. Imagine trying to remember if you used a string for the phone number or the age or the zip code, and you can't remember what you did. So you're just typing away and you're like, I'm definitely sure this was definitely an integer when I typed this up at 4 a.m., right? So what you can do is you do these structs. And basically what it does, it tells you if you're using contact info, which is a struct, you get to set the name field and then what type it is. So name is a string, age is an integer. You know, your phone number is definitely a string because you might have dashes or slashes, or whatever country you're from might need the country code, etc., etc. So what you can do with these, which is super helpful when you get started. So here's an example: my contact information, my age, here's my email, here's my at least where I live, and a phone number. And what you can do before I even type any of this out, if you hover over these things, especially in VS Code, if you're using it, it will tell you. So imagine this is at line 10 and this is at line 200 in a really big file. You can just kind of sort of hover over it and be like, okay, the name is a string, age should be integer, email string, etc. It makes it super easy, and especially when you're starting out and you start trying to do more full stack stuff or bigger applications, using these can help you sort of make sure you don't make any mistakes. And I mean, if you make a mistake, Go will just yell at you before you even compile it and say, sorry, you told me this was an integer, 500 lines up there. Can you make a change somewhere? And when I'll print this out for you. I don't think it's quite as important, but you can at least kind of see, nope, need to run in there. And a misspell. So when you print this out, again, in other languages, this probably wouldn't print out. You'd have to do some sort of manipulation to make it work. But in Go, they've done a super fantastic job, which really helps with debugging. So you don't have to do any crazy work just to see what's inside of something. And then, this prints out exactly what we asked for. So it's coding time. What I'm going to do is I'm going to do a really simple application. And the application, all it's going to do is it's going to take a few inputs from somebody and create a Mad Lib, essentially. I've already pre-selected the Mad Lib, but we might change it a little bit. And what it's going to do is it's going to take input from the user and say, okay, tell me an exclamation, an adverb, a noun, and an adjective, just like the Mad Lib books you get at the store. And then we're going to concatenate those into a big string and print that out so the user can have a laugh. So let's see where we can go. So I haven't done anything in this right now. It's completely empty, and we'll build the whole thing and we'll talk about what we're doing as we're going along. So to begin, we got to put the package in there, and as VS Code is very nice, it will tell you package main is what you need. And then we're just going to import that FMT. It has other functions. In Java, it does things like brings in inputs and it can print stuff out. I won't go into too much because there's quite a lot of things it can do, but you can basically print stuff. You can read stuff from a user off the keyboard, and all sorts of things like that. Now what we're going to do is we're going to declare all the variables that we want to use. And there's going to be 4, one for each piece that we're going to ask the user for. And then at the end, we'll just print them by concatenating them together. So what I'm going to do is I'm going to do it one line for each one, nice and simple, so that we don't have to worry about if I make a mistake. One, if I make a mistake, and 2, it will be the simplest way to basically do this versus like doing too much too quickly, and what you'll either get confused and they'll have a lot of questions, or you might miss something. And I want to make sure that everybody is inclusive here versus me zipping through this. So what we're going to do here is we're going to declare the variable and just set them to empty strings for now. So we're going to have an adverb, set that to a string also. We need some nouns and an adjective. Adjective. There we go. And I apologize that I'm looking over here, but my webcam that I used for live streaming broke, and I can't get another one because the prices at COVID right now are ridiculous. The one I want is about 3x the price it normally is. So I apologize for having to look at the side of my face the whole time while I type. So now we're going to use the FMT, and what we're going to do is we're going to just use print instead of print line, which doesn't add, basically it doesn't add a new line at the end. And what we're going to do is we're going to ask the user to enter, what was the first one? Exclamation. That's it. And then this is the new piece that we've not seen before. So scanline, essentially what it does, it looks for the input from a user, and when you hit enter on the keyboard, that's when it stops looking, and it will put it somewhere. Now, what we could do is just say, like, we can make it a new variable, or we could put it inside of the ones we have.
Can you explain why you've given just empty quotes at the end of each variable, please?
Yes, of course. So this right now, we could just do this, and Go would be happy with that. But I'm just trying to keep it as simple as possible. So this empty quote basically means it's an empty string. So if we were to print this out right now, nothing would print out. It would just be empty. But in Go, we could just do this, and that would be fine. There was nothing assigned to it. Now, if I make a mistake, we'll be able to see it quickly because it will be an empty string when we print it out the other side. But essentially, the reason we're doing it is just for ease, but essentially it's an empty string. So this is going to get a little bit different. So this piece here, we've put this the ampersand at the beginning, and essentially what happens is anything the user types in will now get fed into this exclamation. And that's that in its simplest term. Imagine if you opened up a textbook or a text document, sorry, and started typing and hit save. That's essentially what this is doing. Oops, moving it. It's saying, hey, whatever the user types in, put it inside of here for me, and I'll store it for later, and maybe James wants to use it. And that's as crazy as this application is going to get. So now that we've got the explanation, we're going to need the next set. So we're going to need an adverb now. So now we can start asking for the next one. So let's go ahead and ask for the enter an adverb. And then we'll just repeat this over and over. So there's not going to be any more sort of gotchas or new things that I'm introducing, because I wanted to make sure that this gave you a good understanding of the basics of Go. And this is actually part of my book. It is very much this exact project. It has some slight changes to it, but the idea is that I want to make building blocks, right? Or equivalent if you've got kids, right? And they learn to crawl, then they learn to walk, then we run, and then we sprint. And that's essentially what the book is. It's very much a building block. We start very basic stuff like this, and at the end, you get to build this crazy movie database where you get to do some cool stuff, and you get to pull stuff from APIs and display images and do all sorts of wonderful things. But first, you've got to learn those little tiny basics that give you the confidence more than anything. It's about confidence. If you know, oh, this kind of feature does one, or this feature does something else, it makes it nice and simple. So even if you get overwhelmed with what you're doing, you don't have to, you can go back in the book and say, oh, that's right, James talked about this 5 minutes ago. Let me just read this real quick.
Do we need to put this in a main function?
Yes, good catch. See, this is why live coding is fun. So I got distracted. The function should be here. Good catch, Danny. We'll keep you for another week.
I can't claim this. This is all Janine. I'm just reading the comment.
Good job, Janine. We'll also keep you for another week. Yes. All right. So good catch. But yeah, so if we tried to run this, it just would have just been like, hey, you don't have a main function. What is going on? Oh, like you wouldn't have got very far. Unlike other languages where they'll let you flail around for 45 minutes while you try and figure out why something's not printing. Scan line, and we need the noun this time. So we'll just ask for the noun. And the good thing about this, what are you? Nope, okay. Oh, it's because one good thing and one bad thing. VS Code is so useful that it's too useful sometimes. So right now in Go, it's like VS Code is so good that it'll tell you, hey man, you declared this variable and you've not even used it. Like Go's not going to let you compile this. What are you doing?
Question. Someone
yes.
says they noticed the package is not blocked out. One package per file?
One package per file, yes. Sorry, yes.
Okay.
I assume you're talking about this, right?
I assume that's what the person is referencing, yes.
Okay, cool, yes.
Or add blocks if you're declaring other packages in the same file. Could you add other packages?
Yes. So if you have a bunch of packages, right? So let's say you have a big program and you've got 5 or 6 packages. You can actually do, it's a bit more in depth, but yes, you can add hundreds of packages.
Turn this up. There we go.
Okay, Nick's good. But yes, you can add, very similar to Java. If you've ever done Java before and you add a bunch of stuff that you need to import, it's the same idea. And you can create your own packages and import those in, and it's super easy. It's a bit more technical than this, but yes. Adjective. So now we have the nice simple sort of layout we have here. Can't type this keyboard. So this will run right now, and I can show you before we do any sort of manipulation or concatenating strings together. we'll just keep it simple and we'll just run this, and I'll show you what it does. So again, you can still use go run, and this is under Mad Libs, and I called it main go. And as you can see, it's asking us to enter something. So we just write hello, right quickly. Oh, right. So it didn't do anything with that code, right? So now it's ended and nothing has happened here. So what we can do now is we'll just do a concatenation. We'll do a nice simple concatenation that probably everybody's seen before, where you just use the plus to do all the string concatenation. And then we can see what happens. So again, in Go, it's very, just so we have a gap between. So we can do something like this, and then we can do our, whatever we want in these strings, right? So this will just add this string together. In Go, there is another way to do this. Instead of using this, you can actually use the comma, and it will add spaces in. So if you were to like hard up this together and we add something on the other side here, delete this, and we wrote something else here, like this would actually add a space in for you, so you don't have to do the space work. For this example, we'll just use the plus for now, but it's something to be aware of, that you can use commas instead of pluses. It looks nicer for some people. Personally, I use a lot of pluses a lot, which is why I'm not going to show it today, but I prefer the plus just because I'm so used to concatenation that way. Before, things like templates and cool things happened in JavaScript where you can do multi-lines and all sorts of crazy stuff that didn't exist when I started. All these cool kids today learning all this new code. So what we're gonna do, I'm making an app. I picked one out. I actually just used Google to pick this one out because I thought, why not? And one thing to note is that you can do as many lines. You can do a carriage return, like I'm doing here, to make it look nice and neat. There's no it's not going to get angry if you move down lines. Unlike other languages where you might have to put this sort of all on one line, this you can kind of play around with. We'll just do convertible. This part's the boring part where you get to listen to me talk. Usually it's much easier than this because usually you're not all muted.
One question that we have that I think relates here is there an easy way to do string interpolation in Go?
I want to say yes, and my mind has gone blank. Yes, there is, and I will come back to it, and I will give you the example. But yes, there is. There's a lot of stuff that we're not covering today, but yes, there's a lot of different things you can do. Okay, so maybe I missed something here. Oh, yep, this is on a new line. Plus. What's to play about here? Oh, yep, because I'm not using. You complaining? Okay. Yeah, because we're not using commas, I can't do the new line, which I just said that you could. Let's see this and how this works out, and then you can kind of see how it prints, how it works, and then we can kind of go into some Q&A stuff, and I can talk about strings and manipulation and all that kind of stuff. So hopefully this will run now. Let's see. We'll do hello, and quickly add crazy. Oop. So you can see that now we've kind of, and I've made some mistakes with my spacing, but the idea is as simple as, everything that we've inputted from the user is now been used and concatenated to another string. And that basically is the end of my presentation, which we can now go into Q&A stuff. But yeah, let's open the floor, Danny, and have some discussions. Let me stop sharing so I can see everybody again, because you're all gone everywhere. And hold on a minute.
Well, I was going to say you could probably share, because I think a couple of these questions may require like a small demo. Hold on. So let me pull this back up, and we'll start from. Do you usually use Visual Studio Code for Go development? You're muted.
Yes. Sorry. Yes. Almost. I exclusively develop in VS Code, with the exception of when I do native development, iOS and Android.
Let me get back on. All right. So one question we have is var1 to int equals 1, 2. Can you do this like you do in JavaScript, meaning var1, 2, and then you can have the equal sign and then 1, 2. You can look in the chat if you want to see that.
Hold on. I'm scrolling through the chat trying to find it. Who asked the question?
Coriano Harris at 7:12 p.m.
7:12. Oh my, you really asking some questions. All right, here we go. Oh, I can't even see that far up. Can you just repost? Yeah, can you repost it? And then I can see what they mean.
Whoops, that's not it.
Oh, actually, I think I see it.
Okay.
Oh, it's because time zones. Time zones, Danny. I'm one. There we go. I'm like 7:12. That was before we started.
I forget. Yeah.
Yeah. Yes. Can you use JavaScript var1 2 equals 1 2? Yes, you can just do that exactly that way. You don't have to put. Is this question asking, can you do this in JavaScript? Is that the question?
He means that can you do that which you would do in JavaScript?
Okay,
but can you do it in Go?
Yes, absolutely, 100%. You don't have to put the type. Go will just infer the type. So if you don't put that, so if you do var1, 2 equals 1 2, it will just say that's an integer. Okay, cool. And then if you try and use a string later, it will just crap out.
But in that situation, it wouldn't be a straight equals. It'd be like a colon equal, correct? No, just straight equals?
You can do a straight equals, yep.
I'll go. All right. Could we use Golang as an object-oriented language like Java?
Yes. That was I felt that was like a trick question, but yes, of course.
All right. Does Go treat semicolons the same way JavaScript does?
In the sense that that's the end of a line. You don't use semicolons. That Go doesn't use semicolons, or I've never used a semicolon. Does that help?
There we go. So it's like Python, no need for a semicolon.
Yeah, exactly. Because like Go was influenced by those, like Java being so and C being so strict, and Python being this flexible, like, oh, we can do whatever we want because we're cool language. So they kind of did the middle.
So question is, what does print look like when a slice entry has an entry containing 2 words?
It prints them together. It just prints like the word and then the word. Actually, let me manipulate some code on my side while we still answer questions, and I'll show you what that does.
While we're getting that set up, do I need to unload the? Can you screen share?
I think so. Yeah. Just give me 1 second. Let me just get through. Okay.
One question is: are there no classes in Go?
No, there are. You can, but the way that we're doing it is because I'm doing some real simple stuff. You can use class in Go, but because we're doing some simple stuff, the answer for this is no, but yes.
Okay. So it says, so someone looked this up. They said, I think the structs are the classes. Yeah, I just looked it up. No classes, structs are Go's answer. So.
Right. Yeah. So when you use a struct, you can use it like a class. And I just want to like, I use them solely as classes, but it's not like, yes, there are classes and structs are basically them. But there's sort of edge cases where that wouldn't be true. But yes, good Googling person.
So what use cases would you utilize Go over something like Node.js?
When you don't want to use Node, I guess so this is like the age-old question, right? So, how popular is Go outside of Google? Or we'll get into that one.
Yeah.
So I guess it's that question of when you decide what you want. So I guess for me, I use Go when I want to use something that's like strictly typed. And yes, you can do that in Node using TypeScript, right? And you can do those same things. But Go usually ends up being much more flexible and much faster in those scenarios where I want to use strict types. And like to whoever asked that question, Chad, I would say 90 to maybe 80 to 90% of my personal development, I don't use Go at all. I will use Node every day. Just because of the support that Node has outside of like a lot of like regular Node packages. There's so many out. There's millions of things that 99% of developers have already done because how popular npm like rocketed Node to be what it is, and how the open source community just was like, oh yeah, we'll build you packages for everything under the sun, which is how I sort of got started. Was I built a lot of Node packages, especially around regex that nobody apparently likes except for me. Nobody likes it except for me, man. Like I wrote a whole package that does some crazy stuff, but yeah.
So before you answer this question, I will answer my little piece. How popular is Go outside of Google? I work for a pretty large company, and I was hired on as a Java developer. I'm a full stack engineer though, but we're literally rewriting our entire code base right now and using Go to create all the microservices. So I can't speak for a lot of other companies, but I do see Go becoming a very mainstream language for a lot of major companies. And even like I was talking about on the live stream yesterday, companies do not migrate quickly to new languages unless there's a major benefit for them. Go is just so insanely fast in a lot of situations that you can't, it's incomparable. So for a company, like especially of my size, to make that move, like it's unheard of. So I think that's the reason why I even wanted to do this, is because I see this becoming a very big deal. So I want people to get the learning resources for it. Now, James, you go ahead, provide your insight.
Yeah, so how popular is Go? So I'll also give you insight. So my company also uses Go. They use Node, but very sparingly. Go is like their go-to language. Everybody that works in the back end, that's all they touch all day, every day. It's become I see Go becoming what Python was about 3 years ago, where suddenly everybody realizes how powerful it is and how good it is at being a technology that people will just start to slowly build, like maybe a few projects here. Ooh, let me just try it out and realize how quick, how flexible, how like it's not resource hungry. So if you look at like a Node project and you look at how many resources you're using because you've imported 300 gigs of npm files, like that doesn't happen in Go. Like applications are teeny tiny, and you only use what you need. So yes, Google did a really good job with it, and I think in maybe 2 or 3 years you'll see what probably Python and JavaScript is now, where it's just like, please, we need Go developers, like come and do this. Yeah, it's definitely good at like high volume stuff, like heavy flow in, and that's what my company does. It's like a lot of load all day, every day. And we're talking like millions and millions of stuff is happening at one time, and like Go's just like, cool, like, yeah, I'll just sit on this AWS server that's not the biggest AWS server I've ever seen, and run and be heavy. So yeah, it's definitely good.
And I'm not one of those people that try to be like, oh, I'm predicting the future here. Like, no. The writing is on the wall for this. Like, Go is going to hands down be one of the next big things
it's
for sure.
definitely
And it's being, and what's weird about Go for me at least is when a company just tries it, you start seeing them migrate. Like, I've never seen any other technology. Like MongoDB, for example, is widely popular, and even they have such a great service. It took them forever to get it picked up off of the ground. Go has just been when they finally tried, they're like, oh, we have to have this. So just really keep that in the back of your mind that in the next few years, you're going to see a huge demand spike for Go, and it's already growing as is. I mean, our company right now, we're literally hiring developers in Go from other coasts and paying them to move here to work for us. So if that doesn't explain it, then I don't know what will. But all right. So it's not a full-fledged class?
Yeah, so it's definitely not a full-fledged class like Java, right? So in Java, you write a class and you write that out. But like what you can do is you can do a struct and it'll have like methods in the struct itself. So I did a really simple one where you just had like a string and an int and things like that. But you can actually do methods inside of a struct and use that to do all of the work, like a class is. Exactly like a class. If that helps.
So Eddie asks, I assume there is support for things like database access provided that are packages provided by vendors.
Absolutely, 100%. It has support for basically your big databases out there. MongoDB, full-fledged, like easy to access. MySQL, Postgres, even Oracle, if you really want to go down that path, they have support for that too. So yeah, imagine it like Java and all the supported stuff. Yeah, it's 100% the same way.
What do you use for unit testing? Sorry.
No, go ahead. Go ahead. What were you going to ask?
What do you use for unit testing in Go?
You can actually just write straight. Like you can just write your you write your own tests. It's really simple. What's the best way to describe this? Basically, you write a function that tests it for you. It's all built into the Go foundation. So there's not like too many external ones. You can just literally write Go test, and it will test the functions afterwards. So you just write like a little file that says, I want to test all these things. You write Go test, and boom, it does the unit tests for you. Unlike Java, where you have to use JUnit, or Node, you might want to use Ava or Mocha or any of the other things there.
So this is a comment, but I know Pete, so this means a lot. Regarding Go versus Node.js, we ended up switching from Node.js to Go to handle high volume log ingestion that was choking Node.js scripts in a retail environment. Now, Pete works for a very big company, so that means a lot. Like, even they switched over as well. Eddie now asks, typical stack server-side tech for web apps using Go, thinking REST services, back-end setup, front-end, blah, blah, blah. So what would be like the typical stack to Go?
I mean, to give you an idea of what sort of like what I use when I build, I use Go with MongoDB, and then Go is so flexible that you don't have to have like a middleware. And then in the front end, you can use whatever you want, whatever framework you feel like. Vanilla JavaScript if you're really scary, like me.
So John gave the wiki history of Go, but Rob asks, do you deploy compiled code or just the code like JavaScript?
Yes, you do indeed do that. Hold on one second. I'm see if I can.
You can't say yes when there's two options.
Build. Yeah, I was going to try and get this to show you what it looks like.
Okay.
Let me just flip back. Let me just share my screen, and I'll show you kind of what happens when you actually build the code. You'll see my screen again?
Yep.
You good? Yep. Like, isn't it? So I'm just going to build slices because that's just happened to be what's open. You see down here, like there's an actual like exe file. Because I'm on Windows and I'm using my Windows, it literally builds it into like a compiled, ready to run, good to go. And then you can, you know, if you're using like a Linux, you can build them out to be Linux, and then you can just deploy them to your AWS server, and it'll boot it all up and run it like nobody's business. But yeah, so yes. And basically, when I do this, the function go run, essentially what it's doing is it's doing that build and then just sort of running it simultaneously. It compiles it all and just runs it internally, so that you don't have to build it, run it, do all that kind of stuff like you would with Java.
So I have a question. So let's say I wanted to learn more about Go. Is there a certain learning resource that I could read that could help me learn more about Go?
Man, I tell you, you should be like a TV presenter. Yes. So I actually put it in the end of my presentation, and then I forgot to share it with you all. So let me share my screen one more time. I promise it'll be the last time. So I talked to Danny about this previously. So my book is available, and I'm giving everybody that came to this 50% off. It is pre-order, but you get the first 4 chapters right out of the gate. So as soon as you pre-order, even if you cancel your pre-order in a month's time, those are for you to keep, and you can play around with them and you can learn a bit. Inside of the book right now, for the first 4 chapters, it's going to go a bit more in depth about all those basic things I kind of covered today. And then on top of that, you get to do your own Madlib application. You can build your own, goes through the same idea. And then you get to build your own calculator, which does all the basic calculations, you know, multiply, divide, add, minus, all those things. And that uses a bit more for loops, and it uses cases and switches and all sorts of cool stuff to build this application out. And to kind of give you an idea of what else is in the book, it does say it on the website, but you're going to get, after that, you're going to build a weather application with some APIs, and then you're going to build the weather application with a nice UI, probably with Tailwind or some sort of CSS that makes, you know, to bolster those skills. And then the final big project that's probably, I think it's over 100 pages long right now, the final project, just to give you an idea of how big this book is. The first 4 chapters are 60 pages long, and they're only getting bigger and bigger. And the last project is a big movie application where you can pull down APIs. There'll be a database involved, and then you'll have like a framework that will build out, and you'll be able to sort of pull in the latest movies or your favorite movies, and use those however way you want. But yeah, that's for everybody. Go ahead. They accept PayPal and credit cards. So hopefully that covers everybody. And if you can't afford that and it's still too expensive, send me a DM, and you still want to learn about Go, send me a DM. We'll figure something out for you. No problem.
Okay, a couple more questions popped in. By the way, definitely get that book. I mean, 50% off, you know, you can't beat that. How well is Go supported versus things like .NET Core or Java in terms of third-party libraries?
It is very well supported in the community, and being bolstered by Google makes it, sorry, my dog is whining outside my office door right now because I have put something in front of it to stop him opening the door because it doesn't lock. Yeah, so third-party libraries are very popular. It's not as easy, sort of like with NPM, right? You can just go to NPM and say, I want to whatever. Google, like you type it in, it comes up with a package, you put npm install, and that's it. It's not quite as easy as that, but the support is out there and it's huge. We actually use a few of them in my book. one chapter is about making a blackjack game, and we use somebody's community created library of cards, which seems like a random thing, but yes.
So that's there. All right. How would deploying Go code look like?
Press the build button in Jenkins. That's a good question. The way so to give you an idea of personal projects, I don't typically deploy too much. Mostly because my time with Golang, like I do it every day at work, so I don't like to use it outside of the office. And in the office, it's all handled by my build team. Like I don't touch any of that stuff. But it is in the book, we talk about deploying your code at the end. But it's probably longer than good 20, 25 minutes of discussion. Because there's a lot of different ways to do it. Basically, it's very similar to like how you deploy Node. You can deploy it 5 or 6 different ways depending on how you want to handle that kind of stuff.
And Eddie kind of said, Chad is hitting on where I was trying to go with my question about tech stack. I should have asked about server architecture, particularly web server software. Is it platform agnostic?
Yes. Let's talk about that a little bit more. Yes, it is. What's good about Go? I'm trying to pull up the resource yes, and whoever wrote about Go Playground, I 100%, million%, whoever wrote that, use that resource. Go buy examples. If you don't want to buy my book and you want to learn about Go, here's another resource for you, absolutely free. Go buy example is the name of the website. Just type Go buy example, and then use the play.golang.org website to do your own sort of play around with it to decide whether or not you want to use it. Because I think what you'll find is that after a while of playing around with it, you'll have fun. It's that sort of thing. And in regards to like the platform agnostic, so the way that Go works, it kind of works like C does when you compile. So if you've ever compiled C before, it compiles to the PC or to the computer or the server or wherever you're running it, right? So if I compile on my PC, it's going to produce an exe file, which we all saw. If you go and do it on your MacBook, Danny, it will produce a file that you can use on a Unix machine. And then if you do it on a server, Unix, so a lot of people that deploy compiled code, it is cross-platform and stuff like that, but 99% of people are deploying on AWS or some sort of Linux server at this point. Yes, native code to the platform.
All right, and I think that's all the questions we have.
Woo.
This was, I think, beyond phenomenal. I think everybody could agree. And you know how you can tell it was really great? Traditionally in a meetup, you will have, your dip where a bunch of people leave. We didn't really have that today. So I think that just shows how well you were doing and how well it was explained. Can you drop the link for the book site? What's the link to your book site?
Yep, let me do it right now. Hold on. I'll drop it right in the chat. Let me get the right one because I just moved from Gumroad, so that was a whole debacle. Here is the link to my... Oh, that went privately to Joe. Sorry about that, Joe. You already know where my book is. There we go. Everybody, there you go. And the coupon code was... What did I make GDG. The coupon code? Was it GDG? Yep. There you go.
And if you want to throw an extra donation to the Help a Brown Boy cause, I am more than happy to take any donations you want to send my way. But great meeting. Bought the book already. Having issues installing though, so I hope this helps me out a bit.
Yes, I do describe how to install in the first chapter. So fingers crossed. If you have any problems, whoever that is, if you haven't left, shoot me a DM on Twitter. It's James_R_Perkins. Just shoot me a DM and we can talk.
Yeah,
for sure.
Matter of fact, I'll send his @ in here just so people can have it.
Yep.
That's his
or you
@
can or you can just go to my website, jamesperkins.io. That. And you can find me there. And you can, my email's on there, my Twitter's on there. My DMs are always open for anybody. You don't have to buy my book. If you have a question, shoot me a DM. I'm pretty quick at answering them, but they're building up because quite a few people have been DMing me recently. So if I don't get back to you right away, it's because I'm probably prepping for DevFest.
I'll be completely honest. I've completely stopped answering DMs. Like I've had to close. I have at least in my Twitter alone over 200 DMs that there's no way I'm going to get to. On Slack, I've had to literally put no DMs on my name.
I saw that.
So people start,
I saw that, and I was like, I don't blame. Yeah, I had one guy DM me like 15 times, and I was like, I haven't read any of them yet because I just haven't had time. But
it's crazy because before I was able to reply to everybody that had a question. Right. Now it's almost impossible.
Yeah, it's getting worse and worse. But I do my best. So if you don't get an instant reply, it's because I'm busy.
And if he's not replying to you, just tweet me. Don't DM me, but tweet me, and I'll get his attention as well, just in case he misses it.
Yeah, you can just tweet at me if it's been a few days and you're like, hey, I DM'd you. Just send me a tweet and I'll take care of it, or an email or whatever you want. And then find me on my YouTube channel. Find me on Twitch. Find me on all those things if you want to learn some more stuff. I do a lot of interview questions. So if you like interview questions, my YouTube channel has a few different languages, but like the idea is the same idea. Like I talk about how they try and trip you up and what they're looking for and all those kinds of things. So.
All right, everybody. I think we're going to call it a night.
Oh, I can go to bed.
Yeah. See, what's weird is like here it's still 8 p.m. So I'm like, all right, like I'm gonna hack some things together for my next like live coding session. So I was like, I need to make something that because I keep trying to. I know I have a bunch of beginners that are.
I saw.
So I keep trying to simplify the ideas to where it makes logical sense, so they can grasp the concepts.
Yeah, that's the biggest issue with live coding is trying to decide like what to do and how to appeal. I did a lot of the front end mentor.io stuff over and over again because that stuff was like easy enough for a beginner to understand and good fun. So.
Yeah. And Walker said this best time to go get dinner.
Very nice. Very nice. We approve. We approve.
All right, everybody. I appreciate you. Make sure you RSVP for DevFest if you want to go. We got 9 amazing speakers. It's completely free. You're going to get a ton of resources. Take advantage of this. And there goes my boy Isaac. He finally decided to be visible.
I had to remind you of something, man. Aren't we going to take a group photo the same way we always do? Have everyone turn on their cameras?
I mean, I already took a screenshot and put it on Twitter, so it's done now.
Oh, okay, my bad.
Yeah.
You were too late. Next time.
He tries to remind me of this stuff, but I was like, But yeah, definitely make sure you RSVP for DevFest. Highly
put the link in the chat for DevFest.
Actually, I know for sure we already got O'Reilly. I'm trying to get one more partner to get some extra resources. So definitely, RSVP there. You can't go wrong there. But other than that, God bless and all that good stuff. Imagine I said something profound, and we'll call it a night.
See you guys. Thank you for coming out. Appreciate it.
Thank you.
Bye.
Have a good one, team.